looking at the following questions. This is preparatory exam for Gauteng Province 2023, Geography Paper 1, 3 hours. That's paper 1, 150 max for 3 hours. All right. So these are the general instructions that by now you should know. Section A, question 1, climate and weather. Question 2, geomorphology. Question 3, geographical skills and techniques, 30 marks. All right. We have to go straight to the questions. Question 1, climate and weather. 1.1 says, complete the statements in column A with the options in column B. Question 1.1.1 says, the dash refers to an area that does not receive perpendicular sunlight. And that was easy. Of course, our answer is going to be the shadow zone or Z, because of the perpendicular. The shadow zone does not receive direct heat, meaning there'll be a lot of all the sunlight will go perpendicular to another section. Number 1.1.2, at night, air on the valley slopes cools rapidly due to dash radiation, which is supposed to be terrestrial radiation. As we know, at night, the land or the slopes lose heat in a process that is referred to as terrestrial radiation, resulting into the air to become cool, hence it will be able to subside. Number 1.1.3, if the dew point temperature is below freezing point in a valley, water vapor condenses directly into a dash pocket. As we know that whenever cold air subsides to the valley bottom, it will result into the development of frost pocket. 1.1.4, in the mountainous regions of Cape Town, people tend to build their houses on the dash facing slopes, because we know Cape Town is situated in the southern hemisphere, and we know in the southern hemisphere the north facing slopes usually receive more sunlight or direct heat, which makes them to be warmer. Therefore, we say in the mountainous regions of Cape Town, people tend to build their houses on the north-facing slopes because they will be warmer. Right, number 1.1.5. 1.1.5, it says, a warm layer of air with cold air above and below. A warm layer of air with cold air above and below it, causing an inversion, is known as, that will be the thermal belt, because we know a thermal belt forms as a result when cold air subsides to the valley bottom, forcing the warm air to rise and will settle in the middle of the valley, forming a thermal belt, whereby below the thermal belt, the air will be cold, and above the thermal belt as well, the air will be cold. That's why they say a warm layer of air with cold air above and below. So that will be the thermal belt. 1.1.6, plants that require more sunlight in winter grow best on the dash facing slopes in the northern hemisphere. northern hemisphere. The question says plants that require more sunlight in winter grow best on the dash facing slopes in the northern hemisphere. So that will be the south facing slopes, because we know in the northern hemisphere the south facing slopes receive direct heat, which makes them to be warmer, and which is, we know warmer conditions are suitable for the growth of plants, because they will require or they will need that sunlight. In 1.1.7, the area of a valley which receives direct sunlight in winter is known as a zone of incidence, because we know well that we saw the shadow zone doesn't receive direct sunlight, which means that the zone of incidence will hence receive direct sunlight in winter. Right. Let us proceed to question 1.2, which says, just move this one a bit. It says, various options are provided as possible answers to the following questions. Choose the correct, choose the answer and write only letter A to D next to the question. Number the instructions telling us to write the answer or to choose the answer between A, B, C, and D. Right. So this is our synoptic weather map. 1.2.1 says the pressure cell labeled A is the dash labeled A. This is our pressure cell A here. As you can see, remember, you can see this is the Southern Africa, which means this is the interior. Right. So over the interior, we have this pressure cell A, which is a high pressure cell, and definitely that will be the Kalahari high pressure cell, or the Kalahari and a cyclone. Because remember, when we say cyclone, and cyclones are high pressure cells. Right. 1.2.2, the direction of the surface air circulation around pressure cell B. Let's check pressure cell B. Pressure cell B is as well a high pressure cell, as you can see here. Sorry, I move this. This is our pressure cell B, which is considered as H, indicating a high pressure. So they are saying the direction of surface. The concept here is the word surface. Let's wait for technology to get back in order. So the direction of surface air circulation around pressure cell B, because since we know pressure cell B is a high pressure cell, so we need to understand the movement or the saturation of air in high pressure cells. So they will be subsiding. This is the upper atmosphere, where there will be convergence. Then on the surface, there will be divergence. All right. So divergence, and as well, since we are in the southern hemisphere, the saturation is going to be anti-clockwise. Right. So if we check our options here, it is clockwise, which is not correct, which makes our anti-clockwise correct. It does not ascend, neither descend, because our focus is on the surface, and on the surface there will be divergence and anti-clockwise rotation. Right. Question 1.2.3, it says the area of elongated high pressure at sea. Remember, to elongate is the same as isobars extending, right? Let's check high pressure cell at sea, right? The area of elongated high pressure cell at sea. This is our high pressure cell, like we know. This is the South Atlantic high pressure cell. So you can see the isobars are raging, or they are stretching, or they are extending towards the land, and that is referred to as raging, which makes our option A to be the correct one. Right. I'll proceed to question 1.2.4, which says weather system D develops because of the impact of the Coriolis force on the air movement between the dash cells. Let us first check what is weather system D. We look for the system D. Yes, this is our weather system D here. And as well, we know that this is it is a mid-latitude cyclone, because we can see the evidence of a cold front and evidence of the warm front, right? So which means if we check again the question, it says weather system D develops because of the impact of the Coriolis force on the air movement between dash cells. Right. Let's check. Between such cells, we have the polar high pressure cell and the subpolar high low pressure, which is correct, because we know what they say, the system develops because of the impact of the Coriolis force on the air movement between the polar high pressure cell and the subpolar low pressure, because we know mainly that's where the mid-latitude cyclones can develop. And as well, we can talk about when they say the subpolar low pressure cell and the subtropical high pressure cells. I think option A and B, they are both correct. Because if you check the polar high cell, polar high pressure cell, that is situated between 60 to 90 degrees. In the subpolar low and subtropical high pressure cell is between 30 to 60 degrees, and subpolar low between 60 to 90. So which makes the two options to be viable. Right. In 1.2.5, it says the map shown above is an example of a dash synoptic weather map because of the dash rainfall experienced over Cape Town. Right. So the map above, if you check the map once again, you can notice there is a high pressure cell dominating the interior. And so the cold front, which has approached the land, the high pressure cells are reaching to the land. There's a coastal presence at the coast. There's also pressure gradient between the land and the coast, or between the interior and the coast. And these are all evidences to prove that this is a winter synoptic weather map. So meaning, so far, we know that the map shown is an example of a winter. So we can take option 2, winter weather map, because of the we say here, there is Yes, so we can go with option number 3 because of the frontal rainfall experienced over Cape Town. When we talk about frontal rainfall, because this comes as a result of the different air masses meeting at the polar front. So that's why we say that the map is a winter map, which as well causes frontal rainfall. So, which means option 2 and 3 for this case, which will be number C, right, as our correct answer. Let us proceed to question 1.2.6, which says, weather system D usually brings dash condition to Cape Town in winter. Let's check weather system D once again. So the weather system D is a mid-latitude cyclone. And as you can see, they're saying this is Cape Town already. And you can see there's a cold front already approaching Cape Town there, right? So meaning, if you check our question once again, it says weather system D usually brings all right. So weather system D usually brings like we mentioned, the system D, let me check again. D is it is a mid-latitude cyclone. So what does it bring over Cape Town? Right. So we know it is a mid-latitude cyclone, which could result into let's check, rainy conditions. Floods is not a weather conditions. Rainy conditions, we know that the mid-latitude cyclones do cause overcast conditions, which makes this one out. Floods out, clear skies out, windy and floods. And like we know, floods are not weather conditions. If you look at option number D, dry conditions and clear skies, not really. Let's check this question once again. Was there a mistake? Let's say. Let's see. All right. Yes. So I think we're going to go with. Oh, no, I think I was dealing it. Although I was doing a different question. So we are still doing question 1.2.6, which says the system usually brings dash conditions to Cape Town, and as we know, dry and windy. The mid-latitude cyclones usually brings wet conditions, which makes option A to be wrong. Warm and rainy, not really, because we know a cold front does not cause warmer conditions over Western Cape. Option number C, cold. Yes, this is a condition caused by the cold front conditions, and as well they cause rainfall, which could be correct because option number D talks about dry conditions. So the conditions that would be cold conditions and rainy conditions, right? Then number 1.2.7, let me first remove this because I made a mistake. 1.2.7, it says the weather conditions associated with pressure cell A. Yes, that is correct. Let us check pressure cell A. Yes, pressure cell A, it is our cell A. It is our high pressure cell called the Kalahari or the continental high pressure cell. So weather system A, we said that is the Kalahari high pressure cell, and we know high pressure cells are responsible for causing let's check the first option. They don't result into rain, so this is out, which makes the answer to be false. As well, option number B, because high pressure cells will not normally cause rainy conditions, especially since we are dealing with winter season. Number C, wind, which makes now this option to be also out because of floods. Option number D, dry conditions and clear sky, which makes this to be correct because we know the Kalahari will cause dry conditions and clear skies during winter season as a result of the inversion layer being below the escarpment, blocking the warm moist air to reach the interior to condense. Right. Number 8, the pressure at the center of pressure cell E. Let us first check pressure cell E. So pressure cell E, yes, you can see this is our pressure cell E, which is a coastal law, as we know well, because there is a law, this L here, which means this is a low pressure cell situated along the coast, which makes this to be a coastal law, right? So the question is saying the pressure at the center of pressure cell E is dash dash down 1004 MB and moves from dash dash along the coast, right? Okay, the pressure at the center of pressure cell E, check options. That's gonna be lower because like we mentioned that E is a coastal law, and as well you can see if we check again here, this is 1000. If you look at this isobar, it is 1004 millibars. If you check this one, the next one 1008, so it means next one 1012. It means pressure is decreasing as we move towards the center, which makes it the pressure to be lower, or it is a low pressure, which makes 1 to be correct. 2 is not viable because they're saying pressure the pressure is not high. How they move? We know that low pressure cells, the coastal laws, they move along the coast from the west to the east, which makes option 1 and 4 to be correct, which is 1.2.8, 1 and 4, 1 and 4, 1 and 3, which means number B will be our correct answer. All right. If we proceed to question 1.3, it says, refer to the infographic on tropical cyclone Gombe below. This is our info graph where we have a satellite image and as well the given information. Right. They say cyclone Gombe has killed at least 53 people since the cyclone swept into northern and central areas of the country on Saturday, March 12, 2022. Data showed that the flooding associated with Gombe destroyed a total of 141,854 houses, along with 69 health centers, 21 water systems, 2,764 electricity poles. A total of 2,265 classrooms were damaged, affecting a total of 216 three pupils and 4,421 teachers. A total of 91,177 hectares of crops were lost, while a total of 1,243 kilometers of roads were severely damaged. Southern Africa has suffered repeated devastating cyclones of the type that used to be relatively rare in the past. Scientists believe climate change is fueling their intensity via the warming of the Indian Ocean. Right. Let's check on the questions. All right. Okay, question 1.3.1. How many tropical cyclones have occurred before tropical cyclone Gombe? Before Gombe, so we go back to, there was A, B, C, D, E, F, and G for Gombe. So before Gombe, how many cyclones have occurred in this area? 1, 2, 3, 4, 5, 6. So there'll be 6 cyclones, right? Number 1.3.2, according to the infographic, what is the scientific evidence fueling intensity of tropical cyclones in the Indian Ocean? Remember, the question is telling us to refer to the infographic to find out what is fueling the intensity, the strength of the cyclone in the Indian Ocean. Now, let us visit the infographic. But I remember while reading, I came across this statement which says, scientists believe climate change is fueling the intensity. So which means, so far, climate change is fueling the intensity via the warming of the Indian Ocean. So we could consider those options, and we say consider climate change, and as well warming of the Indian Ocean. Warming of the Indian Ocean. Right. 1.3.3 says, provide evidence from the satellite image which suggests that the tropical cyclone Gombe has reached the stage of maturity. Right. Let's check on our satellite images to prove that Gombe reached the mature stage. Right. So our satellite image, as you can notice, we have the eye which has developed at the center of the cyclone, and we know that the eye are more developed in the mature stage. So the evidence could be the presence of the eye, at the center of the tropical cyclone. Number 4, discuss why tropical cyclone Gombe will decrease in intensity once it reaches the coastline of Mozambique. So to describe the saying, question 1. Check again, 1.3.4. Describe why tropical cyclone Gombe will decrease in intensity once it reaches the coastline of Mozambique. What will make it to slow down? What will make it to weaken? You see? So they are saying once it reaches the coastline of Mozambique. But if we check on our synoptic map, you can see this is our cyclone Gombe, and somewhere here we have Mozambique, and you know Mozambique is land, right? It's land. Or if you check on the slide image here, so this is Southern Africa, this is Madagascar here, if I'm not mistaken. So if it moves close to this point, it is moving towards land, and we know when cyclone reaches the land, there will be friction. So you could say friction with the land, weakens the cyclone. That's one point. Zulu can talk about that less availability of light and heat supply over Mozambique. Since Mozambique is a land, there will be less evaporation, less condensation, resulting into less light and heat. Because we know the more the light and heat, the cyclone becomes more stronger. So the less light and heat availability, the cyclones weakens or its intensity reduces. We'll talk about as well when it moves towards cooler areas. Over Mozambique, it weakens. Because we know cyclones do not prefer cooler areas. I want to talk about less availability or less moisture over land of Mozambique, which weakens the cyclone, among others, right? But since they were asked for only 2, so we only need to give points based on the mark allocation. Right, let's go back to the question. So we've seen what causes the intensity of the cyclone to decrease, right? To decrease. If they say what makes the intensity to increase, then we shall give the opposite. availability of latent heat, a lot of moisture, less friction of the land, among other factors, right? Question 1.3.5, it says, explain two other elements of tropical cyclone Gombe indicated in the infographic that may have resulted in the damage caused to the infrastructure. Right, so they are asking for the weather elements, right? We're going to talk about weather elements here. We talk about things like wind, rainfall, about thunderstorms, lightnings, talk about things like hail, the overcast conditions. All these are the different weather elements, the strength of the winds and all that, right? However, since the question is telling us to say, explain two other elements of cyclone Gombe indicated in the infographic. So we need to go back to the infographic and try to identify those elements which resulted into damage, right? Let's check. So if you check again our infographic, tropical cyclone Gombe has killed at least 3 people since the cyclone swept into the northern central half of the country. March 12, 2022. Data showed that the flooding associated with Gombe destroyed a total of houses, centers, water systems, and electricity poles. But remember, floods is not a weather element, right? So we need to identify the weather elements. Let us continue. A total of 2 of that classrooms were damaged, affecting pupils, teachers. Hectares of crops were lost. Roads were severely damaged. Southern Africa has suffered repeated devastating cyclones of that type, to be relatively rare in the past. Science believe climate change for the intensity of the cyclone, right? However, here they don't mention about the other elements, but if we check on this other information, let's say if we look at the satellite image, we can see there's a lot of clouds that have developed, which means there'll be a lot of heavy rainfalls. Heavy rainfalls. Let's check the question again. 135. The question says, explain two other elements of 2% made Gombe, indicated in the infograph that may have resulted in the damage caused to the infrastructure, right? Okay, so let's use our blank page to try to explain that question. 135, right? So we can talk about overcast clouds causing heavy rainfalls, which destroyed classes, poles, etc. That's one. Since we know that there are heavy rainfalls, I'm going to talk about heavy rainfalls. resulted into floods, which damaged crops. We know that tropical cyclones, as well as associated with, they are associated with strong winds, damaging electricity poles, poles. Electricity poles. Let's check something on our question once again. So in the infograph, spoke about the infrastructure, destroying water system, health centers. Okay, so we can as well say that heavy rainfalls damaged classes. Let me check another example. Damaged classes, water system, health centers, right? Classes, water systems, health centers, etc. What else can we talk about there? We spoke about, you mentioned about the strong winds, right? Right. Yeah, so they did ask for 2. I think that's enough for our question 1.3.5. Right. Then question 1.3.6. So 136, it says state to hey, that's about that sound. Sorry about that technology. Okay, 1.3.6, it says suggest 2 precautionary strategies that can be implemented in this area to reduce the possible damage caused to the infrastructure during tropical cyclones by flooding, as mentioned in the article. Right. What measures can be put in place to reduce on the possible damage caused to the infrastructure? Because as we know, we cannot control tropical cyclones because these are natural phenomena. However, we can try to put in place strategies or plans to ensure that we reduce on the effects that are caused by these cyclones, right? So, just going to suggest 2, which means what we can do, such as flooding, if we put coastal defenses are such as sandbags along the coast. This will assist in reducing flooding of the land. Secondly, people to move away, people to move away from low-lying areas. So this could well reduce on this could reduce the loss of lives, right? As well build with stronger materials to avoid homes being washed away. Being washed away. Also, need to maintain the drainage systems. Maintain and repair the drainage so that they could easily accommodate the overflow of water, right? So we need to ensure that build better infrastructures that are strong enough, etc. So among other strategies, so if you put this in place, this could reduce on the impact of right. Let's proceed. Question 1.4 says, study the information below. Warning of severe weather. Cape Town, better batten down the hatches. Heavy rain, cold winds, severe flooding, and even light snow are predicted as a battery of cold fronts head to the Western Cape that could bring discomfort and displacement in some areas. The South African Weather Service said this might cause thunderstorms, flooding of roads in both formal and informal settlements, damage to property and infrastructure, loss of livelihoods and livestock, damage to crops, disruption to essential services, and all right. So question 1.4.1 says, identify the weather system shown in the diagram of which the cold front forms part of. So this was a good question or an easy question, which says identify the weather system shown in the diagram. You can see the diagram. You can see the cold front symbol here, and we know this is part of a mid-latitude cyclone. Mid-latitude cyclone, or could as well be referred to as a temperate depression or a frontal depression or extratropical cyclone, right? 1.4.2. Okay, let me write these other names for 1.4.1 just in case for clarity. 1.4.1, we said it is part of the mid-latitude mid-latitude cyclone or a frontal depression. It can as well be called extratropical cyclone or a temperate depression. So all these names mean the same thing. They all refer to a mid-latitude cyclone, right? 1.4.2, it says, what is the main reason why these weather systems are more prevalent or common over Cape Town during winter, as shown in the article? Okay, let's check the article. Anyways, they said, okay. All right, so according to the article, so what is the main reason why these systems are more common over Cape Town during winter? Right. 1.4.2. 4.2. So you could say the mid-latitude cyclone moves northwards. They move northwards. During winter season. Or you could as well say they move in relation to the migration of the sun. Or you could as well say that they follow the latitudinal position of the sun. Latitudinal position of the sun. So this the two are more like the same. However, with the first option, we know that the mid-latitude cyclones, they move northwards in summer. That's why they always try to be close to the land, affecting most of the Cape Town. Right. That was for 1.4.2. We're done. So we continue with question 1.4.3, which says, draw a labeled freehand cross-section through the cold front indicated as A in the diagram. Indicate the other elements preceding the cold front on the cross-section. The freehand cross-section through the cold front indicated as A in the diagram. Right. So in the diagram, this is A here. It's our cold front. So let us draw a cross-section, let's say from A to B. Could I hope that's the cold front? right? And we indicate the weather elements preceding the cold front on the cross section. All right. That's for 1.4.3. Okay. So we need to show a steeple pressure gradient. So this would be our cold front. And we know whenever the cold front approaches the home sector, whenever the cold front approaches the home sector, warm air rises. When warm air rises, it's going to condense. And it condenses, the formation of cumulonimbus clouds that are going to result in two heavy rainfalls, right? So these clouds are referred to as the cumulonimbus. It's a long name. Call them cumulonimbus clouds. Cumulonimbus clouds. And so there will be heavy rainfalls. Let us just say heavy rains. Heavy rains. Heavy rains. This would be the direction of air movement. Will they move from west to east? So the cold sector, we're going to experience low temperatures. Low temperatures. Just recap for question 1.4.3. So this is the cross-section of the cold front. As you can see, the steep pressure gradient. That's the cold front, cold sector, warm air rising, forming the cumulonimbus clouds. This is our warm sector, which has resulted into the warm air, where there are cumulonimbus clouds. So of course, there will be heavy rainfalls and all of that. Right. Let us proceed to question 1.4.5, which says, explain how the weather system identified in question 1.4.1, which is a mid-latitude cyclone, resulted in the development of clouds at B. Right. So we could say, approaching cold front, causes warm air in the warm sector to rise up. The rising warm air condenses forming cumulonimbus clouds, right? Like we mentioned in our cross section, if you can go back, what I said. This is the cold front. So cold front. When the cold front moves towards the warm sector, or warm air is going to be forced to rise. So when warm air rises, it's going to condense, resulting into the formation of the cumulonimbus clouds, right? That is for 1.4.5. Okay. Oh. Okay. Question 1.5, it says, refer to the infographic below on urban heat islands. As you can see, they're saying this is the graph or showing the different, also they can call it urban profile, showing the different land use zones where we have the CBD, the commercial area, the suburban residential, the rural areas, urban residential once again, suburban residential, the park, and the rural farmland. Then here, urban areas can sometimes have temperatures up to 15 degrees warmer than nearby rural areas. Cities are filled with more pavements and buildings, while rural areas have more greenery. Right. Now below is a temperature graph, which shows they show us the borderline, surface temperatures during the day, and air temperature during the day, surface temperature during the night, and air temperature during the night. Right. So you can see here during the night, surface temperatures, they rise, and certainly they rise here. Then the air temperature at night is below the surface temperatures. Okay. Then 1.5.1 says, what is the temperature? What is the temperature over the central business district in the temperature profile? The temperature profile diagram. What is the temperature over the CBD, which is the central business district, in the temperature profile diagram? Let's check. Temperature profile diagram. Okay. The temperature profile diagram, and they're saying it was asking the temperature over the CBD. So the CBD here, as we know, is tall buildings. So if we check at the CBD, use a ruler here. There are lines showing this is 20. 21. This is our CBD here, which is 23. CBD is 23 degrees C, right? 23 degrees. Don't forget to indicate the degrees and the Celsius to indicate temperatures. 1.5.2, it says, according to the article, why will an urban heat island develop at A rather than C? Let's check again. The question says, according to the article, why will an urban heat island develop at A rather than at C? Right, let's check. So this is A. They're saying why are we going to experience the one-hit island at A instead of C, right? But they're saying according to the article, right? So our article here, it says urban areas can sometimes have temperatures up to 15 degrees warmer than the nearby rural areas. Cities are filled with more pavements and buildings, while low areas have more greenery. Okay, I think we've seen some information there. So we could say 1.52, write it here, 1.52, why cities, why urban island develop at A. I think we say because at A comma, there are more pavements. There are more pavements compared to area C, right? So said at A, comma, there are more buildings than at C. I could say that at C, there are more greenery yet to A. So that's why the Lebanese island will be more developed at A as compared to C, because we know pavements, they absorb more heat and retain it, which makes the urban area to be much more warmer than area C, where there are a lot of trees. At area A, there are more buildings, because the more the buildings, the more they create a surface area for a heat. Or we can also talk about buildings having a lot of bricks that absorb heat, glasses, metals which absorb heat, a lot of lights which create artificial heat as well. And then at sea, greenery, that means there's a lot of vegetation which includes trees which consume most of the heat in the rural areas, making it not to be warmer like in area C. Okay. So that is 151, 152. We proceed to question 153, which says, give one reason for the lower temperatures experienced over the park at area B. Let's check area B. So area B, that is the park. You can see at the park, there are a lot of trees, which could be, for example, a green belt. You see, because of the presence of so many of the trees. Anyway, so they're saying, question says 153. Give one reason for the lower temperatures experienced over the park at area B. Okay. 153. Why area B would experience lower temperatures? So we could say a lot of trees which use the heat in that area to make it having lower temperatures, because most of the heat is being used by the trees or vegetation. As well as said where there are trees, that means there's less concrete materials to absorb it, right? So that's what we could talk about at 1.5.3, right? 1.5.4, it says, reflect the temperature graph and give the reason why the temperature of the urban heat island is lower at night than during day. Okay. Why temperature of the urban heat island is lower at night than during day. Okay. This is 154. Okay. What the question was asking, why temperature of the urban heat island is lower at night than during day. So you could say a lot of activities from industries a lot of artificial heat being generated or produced by cars less during daytime, because we know during day all of us in the urban area, which results into a lot of heat being produced or generated, and as well there are a lot of lights during daytime, which produces as well more heat during day. Talk about a lot of activities from industries which could cause pollution, resulting into more heat being trapped by the greenhouse gases. We could as well say less activities at night such as industrial production at night. The land uses heat, which is referred to as terrestrial radiation, so which could result in the temperatures in that area to lower down, right? Okay, so 144, then 155, it says, explain in a paragraph how the development of features using natural materials in the cities can be used to reduce the urban heat island. Development of features. We talk about one, have rooftop gardens. On modern buildings. To cool down, or we could say to reduce. We could say to reduce. To reduce on heat. That's one. It as well say let's check the question once again. It says, explain the paragraph of 8 lines how development of features using natural materials in cities can be used to reduce the urban heat island. I think a rooftop garden that is natural, having plants that are natural, right? As well talk about paid buildings with brighter colors that reflect heat. Because we know that dark colors they absorb, but if you use brighter or lighter colors, they reflect the heat, making the area not to be too hot. As well, we can talk about the use of grass thatched houses, instead of zinc. Also reduces which reduces on heat absorption, because we know the grass will not absorb heat if we compare it with zinc, because zinc we know it does absorb, but if you use the grass thatched houses, their rate of absorption is lower as compared to zinc, right? Talk about having more green belts in cities to utilize the heat, or to use up the heat, so this will reduce on the amount of heat in the city. Okay, yeah, I think for now, yeah, we can stick to those 4. Okay, so next is geomorphology. And question 2.1 says, various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question numbers. 2.1.1, the feature that develops at B, at the waterfall below. That is going to be a plunge pool, because we know the falling water will result into this area to be eroded, developing a plunge pool. 2.1.2, a natural levee is formed by A is out, because levees do not form by erosion. B, deposition of sediments within the river channel. No, doesn't form within the river channel, which makes this be false. C, repeated deposition of sediments on the banks, because we know that natural levees forms at the river banks as a result of repeated flooding. It makes option C to be correct. 2.1.3, it says a floodplain is an area in the dash of a river which experiences flooding during periods of dash discharge. So a floodplain is an area in the lower course. We know that a floodplain forms in the lower course, right? Lower course. This is out, can't form in the upper course during periods of need to be low, periods of high. Let's check. No, cannot be high. It has to be during periods of low discharge, which makes option 1 and 3 to be correct. Wait. 2 and 3. It can't be low. It must be high. So which means this is out. So equals to option 1 and option 4, which makes our option D to be correct. Right. Then 2.1.4, braided streams develops in the river's lower course due to increased deposition, because we know when the river deposits materials in its own channel, the braids on the sand island will develop, creating braided streams. This is 2.1.4. Then we will proceed to 2.1.5. 2.1.5, which says identify the following fluvial feature. 2.1.5, terracing. We don't see things like this nature. The terraces are step-like features. Instead, we're just seeing horizontal landscape and a steep area. This part, the meander. Can see there's a feature of a meander, which this could be correct. There's no oxbow lake. It's not a source, because a source is not a fluvial landform, which makes our meander to be correct. As well, a terrace is a feature that forms due to rejuvenation. Right. 2.1.6, they say the following sketch represents the formation of cause 1. You can see they are showing us erosion, narrowing, meander, neck. So eventually, then this part has been cut off, which forms an oxbow lake. 2.17, A delta can be described as delta, a plain that forms at the mouth of a river caused by deposition, which could be correct. Let's check other options. Deposits built up on the banks of a river. No, this is wrong. It doesn't form at the banks of the river. A plain that forms at the mouth of a river caused by erosion. No, it comes now because of erosion. Deposits eroded from the banks of the river. No, so it makes option A to be correct because the delta forms at the mouths due to deposition. Right. Next question 2.2 says, refer to the diagram below, read the following statements and choose the appropriate ones in bracket to make the statements, which will make the statements true. Right. So 2.2.1, it says, stream A is the captor stroke, the captured stream. Let's check after capture here. The stream A, so it makes stream A to be our captor stream. Captor stream. Why do you say captor stream? Because you can see it was able to erode through the watershed as seen in this other diagram. Go all the way, and it was able now to still headwaters of another river. 2.2.2, lateral erosion or headward erosion is dominant at B. That's going to be a headward erosion because we know this happens when a river erodes backwards through the watershed. It is able to capture another stream. Then 2.2.3, it says river C is identified as the misfit stream because it is too small for its valley. Right. So it is a misfit because it is flowing in a large area. Or it means that there is less water flowing, which means the river becomes too small for that particular area. 2.2.4, the elbow of capture at D is characterized by the 90 degrees or 45 degrees. So it's going to be 90 because if you look at the elbow, it will be an elbow like this. Or as you can see it here, the elbow. Put nicely here, the elbow. So the elbow forms a 90 because if it was 45, it's supposed to be like this, 45. But an elbow forms a 90 degrees, so which makes 90 degrees our correct answer there. 2.2.5, E is known as the wind gap, because that is between the elbow of capture and the misfit. So it makes it to be the wind gap as the correct answer. 2.2.6, the possible cause of river capture is isostatic uplift or reduced discharge. When I say reduced discharge, this is the same as the be less water, and we know the lower the water, the weaker the river. However, isostatic uplift will result into the velocity of the river to increase, making it able to erode through the watershed, causing the stronger river to capture the weaker river. So the isostatic uplift will be our correct answer. Number 2.2.7, after river capture, river A River A will increase its volume, of course. The river A is the capital stream, which means it gained more water volume after capturing the other river. Then 2.2.8, River C will have a larger stroke, smaller drainage basin after capture. It's going to be smaller because it lost its source. So it will be smaller, right? So we proceed to question 2.3. It says, study the following diagrams on the process of river rejuvenation. Right. So that's showing us rivers enters into the sea. This is the sea. This is our river. The meandering pattern. This is the sea. Because of course the sea, it is wider as compared to the river. The saying sea level drops and the river cuts into the flood plain, as you can see here. The sea level has dropped. The river continues cutting backwards. Right. Then 2.3.1, it says, let's check the instructions. So the following diagrams. All right. Choose the correct options in brackets. That is our instructions. River rejuvenation is when the erosive power of a river increases, resulting in an increase in vertical erosion. As we know, when the river gains more energy, it will start cutting downwards, which is the same as vertical erosion. 2.3.2. Determine the cause of river rejuvenation as shown in the diagram above. Okay. I think, as we all know, to be drop in sea level. Sea level. As you can see, here was friction. The moment it was dropping the sea level, the velocity of the river increased, which made it able to start cutting at the river mouth. In 2.3.3, explain how river rejuvenation results in the formation of river terraces. 2.3.3, explain how river rejuvenation results in the formation of river terraces. That is 2.3.3. Okay. So you could say a river gains more energy and erodes downwards, stroke vertically. Then the previous floodplain will be left at a higher point. And a new floodplain develops. Forming terraces. Okay. So to question 2.3.4, identify the landform at B associated with river rejuvenation. Landform at B. This is our point B here, which could be waterfalls, rapids, or lake points. 3.4. Talk about waterfalls, rapids, and lake points. Any of those ones, because we know the river is cutting vertically downwards through the landscape, resulting into the formation of waterfalls, rapids, or lake points. 235. Describe how erosion causes landform B to retreat or to move upstream over time. 235. The question says, describe how erosion causes landform B to move upstream over time. Okay, landform B, which is a waterfall, rapids, or lake points. Right. This was our blank page. Would say headward erosion with erosion removes the non-resistant layers due to undercutting of the non-resistant layers resistant layers will break away due to no support the waterfall, then move upstream. So basically, here we are saying, for example, let's use this example here. This is our waterfall. And now the question is asking, why is the waterfall going to extend to this point here? See, because it used to be at point A, but it has now moved upstream to point B. What is causing this? So this happens basically where we have the non-resistant layers of rocks, and we have the resistant layers. So in most cases, the river keeps on eroding away the less resistant layers, and this is going to happen. See, see the resistant layers. Now, after this part being eroded away, this part used to have the less resistant layers, but after them being eroded away, and what happened? They are eroded away. So meaning that the resistant layers of rocks will have no support, and eventually they are going to break. This part breaks off. If it breaks off, it means now the water flow is going to extend and to be at this point. It used to be at this point, but now it has moved backwards upstream to this particular point. So that's how we could explain the also could explain how the landform at B or how the waterfall moves upstream. Right. Then we got 2.3.6, which says predict how the narrowing of the original floodplain will negatively impact agriculture activities. Okay, would say if the floodplain becomes narrow, that means less farming takes place. When there is less farming, it means also produces on food production, because food security, insecurity, challenges to access water from higher grounds. Therefore, we know that when the floodplain narrows, it means most of the area has been undercut vertically, resulting into less land available for farming, and as well it reduces on food production, causing food supposed to be food insecurity, not security, causing food insecurity. And as well challenges to access water from a higher ground, because remember before it used to be a flat land next to the river, but because of vertical erosion, the land has become steeper, meaning those areas people struggle to access water. Right. Proceed to question 2.4, which says study the diagram below that shows the fluvial course of a river, the fluvial courses of a river, upper course, middle course, and lower course. Right. 2.4.1 says, would the flow in the upper course of the river be characterized as turbulent or laminar? And we know this would be turbulent. So turbulent occurs in the upper course of the river, where the river profile is ungraded due to a lot of temporary base levels of erosion being caused by vertical erosion. So the flow is going to be turbulent. The river does not flow over a smooth concave profile. Right. 2.4.2 provide evidence to the diagram to substantiate your answer to question. Why do we say it is turbulent? Which we just mentioned. Could say river flows over a steeper area. The river channel is not smooth. Not smooth. And as well, we could say there are a lot of temporary base levels of erosion in the upper course. Right. Then 2.4.3 define the term cross profile. In the cross profile, we look at the shapes of rivers at different stages. Profile showing or shows shapes of river at different stages. That's why we're able to tell, able to see the V shape, the U shape, or the flat shape. Right. 2.4.4, it says, for the middle course and the lower course, which of the following course profiles represents the middle and the lower course? A middle course would be middle course would be C. This would be middle course, because you can see it is U shape, a bit wider. Then the lower course to be A. You can see it is very wide, less, very wide and shallow for A. So it means A is the lower course, then C is the middle course. Of course, B will be the upper course, because you can see it is very deep, forming a V shape. This will be our upper course. Right. Number B, describe the shape of the river valley in the middle and the lower course. 244B. For B, just a blue color. So describe the shape of the river valley in the middle and the lower course. Middle course would say it has a U shape valley. U shape valley, it has to be a U, not a V. to the U shape. In the lower course, valley would say the wider U shape or opened U shape. Alright, as we saw earlier, the lower course is almost very flat and very wide. The middle course forms a U shape, which is a bit deep. Okay. Then 2.4.5, it says, explain how fluvial processes throughout the river courses result in the formation of the valley shape of the lower course described in question 2.44b. Right. So our 2.44 says, I'll check the question once again. It says, explain how fluvial processes throughout the river course result in the formation of the valley shape of the lower course described in question 2.44.b. Okay. Okay. So let's see how the shape of fluvial processes throughout the river course result in the formation of the valley shape of the lower course. So it said, that lateral erosion eliminates the lower course, resulting into a wider U shape. Okay. As well, would say more deposition, of the sediments, of course, causes the channel to be shallow. Right. As well as say the speed or velocity decreases due to gentle gradient, causing more deposition. Okay. Or as well as say solid sediments in the upper middle course are deposited Right, just to add on something here, why the lower course has a wider U shape, like we said. This is our shape here, for example. This is our shape. This is the way different from this. This is a U shape. This is a V shape. So they're asking why the lower course has this kind of shape, and we said here, due to lateral erosion, because lateral erosion, when a river erodes its banks or its sideways, making the channel to be wider. So lateral erosion dominates the lower course, cause the lower course are resulting into a wider U shape, or more deposition of the sediments in the lower course. In the lower course, in the lower course causes the channel to be shallow. Because you can see that this one is deep. Also, this one is deep. Actually, the it was supposed to be like this, the middle course. See, and this one is very, very deep, the upper course. However, since our focus is on this, the lower course, we're going to say more sediments are being deposited in the lower course, causing it to be shallow and not deep. And number 3, the velocity decreases due to gentle gradient, causing more deposition. Because we know the steeper the gradient, the higher the velocity, but the gentle the gradient, the lower the velocity. So meaning the speed of the water reduces, which causes sediments to be deposited in the lower course. Okay. Proceed to question 2.5. Talks about study the information below on river management. Lebanese River Healing Plan, a roadmap for African cities to cope with climate floods. Right. Just to go through the article. Water is the source of life, yet it is also one of the most terrifying forces of nature. This became clear during the recent torrential rains in Durban, when flood waters in 18 local river courses ripped away hundreds of informal houses and dozens of carefully engineered steel and concrete bridges. Instead of allowing the free flow of water, the accumulation of debris can turn bridges into the equivalent of dam walls. When that happens, the power of water is strong enough to smash down obstacles like bridges. Geoff Toll, P.1 Senior Manager for Coastal Stormwater and Catchment Management, estimates that more than 80% of the destructive river blockage in April was due to alien invader plants and litter. P.1 Mayor Police Kaunda says well-managed catchment areas provide over 4 billion in revenue for services to our city and its residents annually. These waterways are not only responsible for providing water, but they also help regulate the impact of heavy rains and floods if well managed. Right. Our first question says, define the term catchment management. Define the term catchment management. That is 5.1. Could say So I could say catchment management, ensuring good use of rivers or drainage basins, or proper use of rivers and ensuring that rivers are not mismanaged, not mismanaged. Let's continue. Question 1.5.2. Identify the human contribution to the flooding in Durban from the article. Okay, the article, let's check. The article, the human contribution to flooding. Okay, so we will identify about litter, which is the same as pollution. Let's check again here. Okay, measure debris. Okay, right. So we could talk about things like planting of alien plants, about litter as well. Litter, which same as pollution. Then 12.5.3, use evidence from the pie chart graph to explain why the Etiquette municipality has found it challenging to maintain catchment areas. Okay, let's check ownership. So I could say the Etiquette only owns it only owns 23% of Durban rivers. As you can see the pie chart, only owns 23. The majority is being owned by the private. Then 254. Why is the maintenance of the catchment areas financially important for the eThekwini municipality? I think we saw something here which says the eThekwini mayor police council says will manage the catchment areas provided over 4 billion in revenue. So I could say well managed catchment areas provide well managed catchment area provides 4 billion in revenue. Then 255 in the paragraph the paragraph of 8 line proposed 4 ways in which the eThekwini municipality can ensure that residents of Durban can be encouraged to assist in the catchment management. It's 255. Catchment management. So residents should be educated avoid building in or near rivers to create buffer zones. Reduce encroach on rivers as well. Educate people about river catchment and management. River catchment and management. And as well create programs to ensure that rivers are kept clean and safe. Expansion of wetlands. Okay, etc.